Okay, so in this lecture, we'll look at integration by parts. Integration by parts is a method that is used in order to integrate two functions that are multiplied by each other. It's just a method. So how it is used? So let's say we have this example, x to the ex dx. I've wrote the dx here because it's kind of important. How do we go about integrating this function? Well, we can use integration by parts. Integration by parts is a method, as I mentioned, of integration that is used where two functions are multiplied together. So how does it work exactly? So if you remember the example that I just showed you, it is x times e to the x dx integration. So it is this side. This is the rule of integration by parts. We have this side is given to us. Two functions are multiplied, and the rule says it is equal, this side equals uv minus integration of v du. So when we have two functions, we assign u to one of them and we assign dv to the other one. Once we do that, we find du and we find v. So we go down, we find the derivative of u, which is du, and we go up, we try to find the antiderivative of dv, which gives us v, and we put it back in this equation. It gives us the integration of the two functions that are multiplied. So how do we know that which one is u and which one is dv? Well, that's totally up to you. You assign u to one of them and dv to the other one. When you do that, let's say you have x here and ex here, you assign u to the x and dv to the ex. You proceed, you see if the integration is done. If the integration gets increasingly more complicated, then you have done something wrong. Probably you should switch back and you should give u to the other one and dv to the other one. So let me give you an example to make things clear. Let's say we have this example, x to the ex dx. We want to find the integration of this function. We have two functions multiplied. So in this case, I will assign the u to the x and the dv to the e to the x dx. So this is our rule. I'll assign u to the x and dv to the ex, and this is this side. So if I do that, I want to find du and I want to find v. So I want to go down and find the differentiation of u, and I want to go up and find the antiderivative of v. So the antiderivative of dv is v, and it gives us ex because the antiderivative of ex is just ex, and the differentiation or the derivative of u, which is du, equals 1 because the derivative of x is just 1. So let's put everything back into this equation and see if we can get the integration. When we do that, the integration of x ex dx equals x to the ex, because u is x and v is ex, minus the integration of e to the x, because du is 1 and v is ex, so it is just integration of e to the x, and this is equal to e to the x minus ex, because the integration of ex is just ex. And as you can see, we have done it. We have done the integration. It is very, very simple. It goes like that. So the integration of x to the ex equals x times e to the ex minus ex, or ex times x minus 1. So this is basically the integration by part. When you have two functions multiplied by each other, you assign u to one and you assign dv to the other one. This is the first step. Once you do that, the second step is to find du of u and v of dv. You find the derivative of u and the antiderivative of dv. Once you do that, the third step is to put it back in this equation and you see if you can get the integral. If the problem gets progressively more complicated, maybe when you assigned u and dv, you did something wrong. You should switch back, and don't forget that you have a minus right here, because if you put a plus, everything will get wrong. So the rule is the integration of u dv equals uv minus the integration of v du. Let's check out another example. Let's say we have the integration of x times sine of x dx. How do we do that? Well, again, we'll assign u to the x and dv to the sine x dx. So we have to find the antiderivative of dv, which is minus cosine x, because the antiderivative of sine x is minus cosine x. The derivative of v, which is dv, which is minus cosine x, is sine x. And we have to find the derivative of u, which is 1. Du is 1. So let's put everything back into the equation. So x times sine x dx equals minus x cosine x, because u is x and v is minus cosine x, so it becomes minus x cosine x minus, but as you can see, we have a plus right here. I'll tell you just in a second why we have a plus the integration of cosine x. Here we have v du. Du is 1, v is cosine x, but here we have a minus. This minus comes out, and when we multiply it by this minus, it becomes plus. That's why we have a plus right here. So it becomes plus the antiderivative of cosine x. The antiderivative of cosine x is just sine x, and here we have minus x cosine x. So the antiderivative, or the integration of x times sine x dx, equals minus x cosine x plus sine x. We assigned u to one of them, dv to the other one. We found the differentiation of u and the antiderivative of dv. We put it back in the equation, and ta-da, we got the integration of these multiplied functions. So integration by parts is a method of integration that is used when two functions are multiplied together, and this is the rule of it. And please don't forget that you have a minus right here.